Hello everyone, we are interested to derive or to get the equation for the average DC current which flows through the load resistance RL in case of the half-wave rectifier circuit. Here you can see this is the circuit which is called as the half-wave rectifier circuit. It's consisting of one diode and resistor connected, and we know the theory. If not known, I will just revise it in very short. We know that here the input is AC, means it will be having positive and negative half cycles as shown. This is the diagram, or this is the waveform of the input. To this applied input, what will happen? The diode will conduct during forward biased. So when we are having this positive half cycle, the diode will become forward biased and it will conduct. As a result, we get this waveform at the load resistance RL. During negative half cycle, the diode will become reverse bias, hence there will not be any current flowing because the diode now will act as a open circuit. Again, when the next positive half cycle is coming, the diode will become forward biased and it will again conduct and will get the waveform like this. So this is the final waveform which we are getting at the output. Let us consider that this is the peak value of the current which is available at the output, as we are interested in deriving the equation for average DC load current. That's why I am taking the notation in terms of current. So approximately the maximum value of current can be same here. So in that way, with this brief theory, let us go for the equation. Let us consider the equation can be written. Let me first notate this up to from this 0 to pi, and this is pi to 2 pi, and hence on it will go on. Now the equation for this current can be given like IL is equal to Im sine omega t. This is the current, but in which duration? Only from 0 to pi. So here it is necessary that I should write for 0 less than or equal to omega t less than or equal to pi. So in this duration we are having the equation Im sine omega t. Now after this, from pi to 2 pi, there is no value of the waveform, or the output is 0, and that's why I can write here is 0. So for omega t which is greater than pi but less than 2 pi, we are having it is equal to 0. Understood this equation? Once again I am telling that from 0 to pi we are having this equation, that is Im sine omega t. From pi to 2 pi, as the output is 0, so that's why the current equation is written to be 0. Where I already told you that this Im is nothing but the peak value of the load current, right? Now we are interested in the average value of the DC current. So the equation for the average value of the DC current is given by IDC, which is nothing but the average value of the load current, and the equation can be given like 1 upon 2 pi integration 0 to 2 pi IL d omega t. So this is nothing but the integration of the current over the period 0 to 2 pi. Why 0 to 2 pi? Because 0 to 2 pi is nothing but it is completing one complete cycle here, right? So now further, as we know that the equation of IL is 0 from pi to 2 pi, and that's why further what we can do is we can take the equation like 1 upon 2 pi in bracket, it is 0 to pi, this value, that is Im sine omega t, and this d omega t, plus this value. But now the integration limit changes from pi to 2 pi, and here the value is 0. Getting right, and the bracket is completed here. Okay, now further this will become automatically 0. So now we are remaining with only this term, and as a result what I can write is IDC, that is nothing but the average value of the DC current, is 1 upon 2 pi integration 0 to pi. This Im I can take outside also, so that is Im sine omega t d omega t. Getting? Now after this we are going to solve this. So integration of sine is nothing but minus cos. So further solving I can write here, it is Im by 2 pi. Now we are going to take the integration of sine, which is nothing but the minus cos omega t, and now the limits are 0 to pi. Right, now further we have to solve it. So now after solving it further, what I can write is, it is Im by 2 pi. The minus sign I can take outside also, right? So in bracket now I am remaining with cos pi, this minus cos 0. Okay, now we have to put the values of cos pi and cos 0. So now we know that, so this is Im divided by 2 pi, the minus sign as it is. Now what is the value of cos pi? It is minus 1. And what is the value of cos 0? It is 1. So it is minus 1 minus 1 means become 2, and this 2, that 2 will get cancelled. So lastly what I am remaining with is Im by 2 pi, this is minus sign, in bracket I am having minus 2. So finally solving, what I will get, the value of DC current, that is IDC, is equal to, now 2 will get cancelled, minus minus will become plus. So finally I am remaining with Im by pi. So that is nothing but the average value of the current which is flowing through the load when the circuit is connected in the configuration called as half wave rectifier.